For our next example, we're going to look at the cube root of x cubed plus 56 equals x plus 2. Well, the good news is that the radical is already isolated. What power do we raise it to here? We need to raise it to the third power. So there comes the bad news. The bad news is we are going to have to cube a binomial. Right here, raise both sides to the third power. Remember that you're not allowed to just say over here that this is x cubed plus 8. You have to actually write it down, square double square it, or FOIL it out, whatever it takes to get that cubed out. So the left side becomes x cubed plus 56. So we're done with that pretty fast. The right side, on the other hand, is x plus 2 times x plus 2 times x plus 2. So the first thing I'm going to do is multiply the first two factors together. So we'll keep the left side, and over here we will have x squared plus 4x plus 4, all multiplied by x plus 2. Now we need to multiply x squared plus 4x plus 4 by x plus 2. So we'll keep the left side, and the right side will become x squared times x is x cubed. I guess I don't need the parentheses anymore. X squared times x is x cubed. X squared times 2 is positive 2x squared. That takes care of distributing to x squared. Now we need to distribute this 4x. 4x times x is what? 4x squared. And I'm going to write them under each other like that just so I can kind of keep up with my like terms. Now we stay on the 4x and multiply it by the positive 2. 4x times 2 is positive 8x. So I've already distributed the x squared. Now I've distributed the 4x, and I have the 4 remaining to distribute. 4 times x is positive 4x, and 4 times 2 is positive 8. So if we tally all of that up, we get the cubic equation x cubed plus 56 equals x cubed plus 6x squared plus 12x plus 8, which looks really daunting. But the good news is that when I start trying to get it equal to 0, what happens to the x cubes? They go away. So if I subtract x cubed and 56 from both sides, I'm actually left with a quadratic equation. 0 equals 6x squared plus 12x minus what? 48. Better news. What can I factor out of all three of those?
6.
A 6. So now we have 0 equals 6 multiplied by x squared plus 2x minus 8. And then that quadratic here factors into x plus 4 and x minus 2. So it looks like I have two possible answers. Now, does this 6 produce a solution? No, because 6 can't equal 0, right? Okay, so we ignore that one, but the x plus 4 will give us a possible answer of x equals negative 4, and the x minus 2 will give us a possible answer of positive 2. And we need to go and check them both. So we need to check negative 4 and positive 2 back into the original to see if they work. So we checked them both, and both of them work, so we can list them both as solutions. One more example? Let's do it. Example 6. I know you can tell just by looking at this that this is going to be the fun one. What makes it look so bad?
Two radicals.
It has two radicals. Well, the first thing we were told is that you need to isolate one of the radicals. Doesn't matter which one. So you guys tell me, which one do you want to move to the other side?
2x plus 3.
You want to move that one to the other side? Okay. So we're going to move the square root of 2x plus 3 over to the right. And when we do, that leaves us on the left with the square root of x minus 2 equals 4 minus the square root of 2x plus 3. So far, so good? Okay, now I need to raise both sides to which power?
2.
To the second power, so I need to square both sides. The left side drops down to x minus 2. The right side is where people have their trouble. When I have to square that binomial with that radical in it. So I'm going to talk you through a couple of ways to do that, and you can just latch on to the way that works for you. The first way, if you are very, very good with square, double square, most people can do this with no problem. I simply square the first, so if I square 4, I get
16.
multiply all of this together, and I get negative 4 square roots of 2x plus 3, and double it. So you double the product, which instead of just negative 4, it's negative 8 square roots of 2x plus 3.
That doesn't the radical go?
So there's your middle term. And for the last term, when you square a negative, you always get a positive. And when you square a square root, the square root just disappears. So that's one way that you can work that problem. You can just sort of do it in your head, square, double square. If you are not comfortable with that, go off to the side somewhere, write it down twice, and literally foil it out so that you can see what's happening. I can show you in a minute how to do that if we need to. From here, we need to clean it all up, and the problem is we still have a square root remaining. So we have to re-isolate the radical
Before we do anything else.
before we do anything else. We have to start over, basically. We still have a radical left. So this is one of those problems where you have to start over. So I'm going to go ahead and try to combine some like terms here.
Just move the 2 into x16.
Yeah. How do you guys want to do this? You tell me. Some of you have already started it.
Make 19. And then
Okay, so you just go from there. X minus 2 equals 19 plus 2x minus 8 square roots of 2x plus 3. Which side do you want to take the radical to? Left or right?
left.
You want to go to the left?
Yeah.
Okay, so the radical goes to the left and becomes positive 8 square roots of 2x plus 3. That means I need to take the x to the
Right.
right and the 2 to the right. So I'm going to subtract x and add 2, giving me 21 plus 1x. Is everybody okay to here? Anybody want to turn that around, write x plus 21? Me, I do. I don't like it. So let's do that. We have 8 square roots of 2x plus 3 equals x plus 21. Now at this point, technically, you could go ahead and square both sides, but how many of you want to divide both sides by 8? That's fine too. If we go ahead and divide both sides by 8, we get square root of 2x plus 3 equals x plus 21 all over 8. Don't let that scare you too much. Looks weird, but just leave it there. Everything's going to work out okay in the end. Now let's square both sides again. The left side produces 2x plus 3. The right side, we have to square the top and the bottom. So let's focus just on the top. X plus 21, quantity squared, is a binomial squared. So that's x squared plus 42x plus, what is 21 squared?
441.
441. All over what?
64.
64. It looks terrible, but it's about to get better, I promise. Once you do that, you square both the top and the bottom. Write the left side over 1, and then cross multiply. And things should start to fall out a little prettier for us. So when we cross multiply, we get 128x plus what?
192.
192. 3 times 64 is 192. Equals x squared plus 42x plus 441. Starting to run out of room up here. That's a quadratic equation, so let's get it equal to 0 and hope it factors. Don't give up, guys. We're almost there. Subtract 128x from both sides and 192 from both sides. So we have 0 equals x squared minus
Negative 86.
86x
Plus 249.
plus 229.
49.
249. Let's try that again. Oh, goodness. Long problem? You're hoping I don't give you any quite this long to do on your own, aren't you? The main problem with this, not only that you have to start over and you have to re-isolate and you have to square everything again, the numbers are so big, and that's kind of scary to us. Let's stick it out and see what we can do here. Let's see if it'll factor. Amazingly, it does factor into x minus 83 and x minus 3. That gives us two possible answers, x equals 83 and x equals positive 3. We need to pause here, go back to the very original, and check both of them to see if they make it equal to 4. So pause for a minute, go and check both of those answers and see if they both work. When we substituted 83 in, it didn't equal 4. What did it equal? 22. So 83 must be extraneous, so we have to discard it. But when we substitute 3 in, we do get 4. So x equals 3 is our solution.